Hey everyone, welcome. So have you ever stopped to actually wonder how the apps on your phone talk to the physical screen you're tapping? Or how just a random string of text can magically turn into a massive, colorful video game? I mean, it kind of feels like magic, right? But it's actually all driven by some pretty fascinating tools.
Today, we're going to master the foundations of information and communications technology, or ICT. Think of me as your personal guide on a quick classroom tour through the digital universe. We're going to explore the tools, the hardware, and the software that quite literally keep our modern world running. And hey, don't worry if some of these terms sound a little complicated at first. We are going to break them all down together.
Here's our agenda for today's explainer. First, spinning for ICT vocabulary. Second, hardware versus software. Third, tools for careers and life. Fourth, safety first with equipment. And fifth, we'll wrap up with the final tool quiz.
All right, let's jump straight into Section 1, Spinning for ICT Vocabulary.
You know, before you can build a house, you gotta know the names of your tools, right? Well, the exact same goes for technology. So let's get our foundational vocabulary locked in. To make this a bit more fun, let's give our virtual vocabulary wheel a spin. Imagine this giant wheel rotating with all sorts of tech terms and icons. Motherboards, lines of code, apps, the whole shebang. Let's see where it lands first. Okay, looks like our first word is computer. Now at its core, a computer is simply a programmable device that stores, retrieves, and processes data. Whether it's that heavy desktop sitting in your school lab, the sleek laptop on your desk, or even just the smartphone right there in your pocket, if it takes in information, processes it, and spits out a result, it is a computer.
Let's give it another spin. And we land on ICT, which stands for Information and Communication Technology. This is the big picture right here. ICT is the entire infrastructure and all the components that make modern computing possible. We're talking about the digital tools, the networks, the internet, and all the equipment that allows us to communicate globally and solve complex problems every single day.
Spinning again, and we get application. In the computing world, an application, or just an app for short, is a software program designed to help you accomplish a very specific task. Just think about the apps you use all the time. You've got one app for taking photos, maybe another for messaging your friends, and another for learning a new language. Each of those was designed by a programmer to solve a specific daily problem for you.
Let's keep that wheel moving. Next up is hardware. Now, hardware refers to the actual physical parts of a computer system. This is the stuff you can physically touch and feel. It provides the solid, tangible platform where all the work actually happens. So your keyboard, your monitor, the cables, the routers, the internal circuits, that is all hardware. Without it, absolutely none of our digital tasks would be possible. And for our final spin of the round, we land on software. If hardware is the physical equipment, software is the invisible set of instructions, data, or programs used to operate those computers and execute tasks. It's literally the code, written by programmers, that tells the physical machinery exactly what to do and when to do it.
Moving right along to Section 2, Hardware versus Software.
So people actually get hardware and software confused quite a bit, so let's put them side by side to make the distinction crystal clear. Hardware is your tangible platform, the desktops, the routers directing network traffic, the physical cables. Software, on the other hand, is the programs and applications, like your web browsers or the integrated development environments or IDEs that programmers use to write code. Think of it kind of like cooking. The hardware is your physical kitchen, right? The oven, the pots, the pans. You can physically touch all of that. The software is the recipe. You obviously can't bake a cake with just a piece of paper, and an oven isn't going to bake anything without instructions. You absolutely need both working together to get that final result.
All right, Section 3, Tools for Careers and Life. Whether you want to write the next massive hit mobile game or be the person who fixes complex server networks, you're going to need some highly specific tools. And we can actually categorize these tools by career path. On the programming side, you're looking at software tools, things like IDEs and code editors, version control systems to track all your changes, and compilers that translate human-readable code into machine language. But if we look at computer system servicing, well, those are physical hardware tools. We're talking screwdrivers and pliers to actually open up computer cases, multimeters and cable testers to check electrical currents, and cleaning kits to clear out the dust. It's two completely different sets of tools for two incredibly vital tech careers.
Let's look at how these tools actually solve daily problems. Picture this. Step 1. You're right in the middle of studying and the network completely goes down. Your Wi-Fi signal just drops. Super frustrating, right? Well, enter Step 2. An IT technician arrives.
They're going to use diagnostic software to digitally check the system's performance, but they'll also pull out a physical multimeter to check if the network cables are actually receiving the proper electrical voltage. By combining those software and hardware tools in Step 3, the issue gets quickly identified, a broken cable gets replaced, and boom, your Wi-Fi connection is restored. That is career efficiency in action.
Okay, on to Section 4, Safety First with Equipment.
Welcome to the lab station. Whenever we're dealing with complex hardware, especially electrical components, keeping ourselves and our really delicate tech equipment safe is our absolute #1 priority. The crucial takeaway here is responsible handling. For instance, when you open a computer case, you must wear an anti-static wristband. Why? Well, because the static electricity naturally stored in your own body can literally fry a delicate motherboard in an instant. You also need to strictly follow the manufacturer guidelines, store everything properly so cables don't fray, and use those cleaning kits. Honestly, dust is a computer's worst enemy. It acts like a thick blanket, causing parts to overheat and completely fail. Keeping it clean keeps it alive.
And finally, Section 5, the final tool quiz. You guys are doing absolutely great. Now, let's wrap up our classroom tour with a quick, low-stakes final quiz just to reinforce everything. Let's see if you can identify these tools based on their specific tasks. Here is your first question. I'll give you a second to think about it. Which software tool is commonly used to manage changes in programming projects over time, especially when a whole team is working together?
Got your answer? If you guessed version control systems, you are correct. Tools like Git act almost like a magical time machine for your code. If a whole team is working together and someone makes a mistake that breaks the program, they can just use this tool to hit undo and roll back to an earlier working version without losing all their hard work.
All right, question number 2. Let's switch gears from programming software to servicing hardware. Which servicing tool helps measure electrical values like voltage or resistance?
And the answer is the multimeter. As we saw in our Wi-Fi outage scenario, this hardware tool is absolutely essential for safe operation. What's actually really cool about this is how a technician uses a multimeter, basically the exact same way a doctor uses a stethoscope. It lets them check the literal electrical health of the computer to pinpoint exactly where the problem is.
And that brings us to the end of today's explainer. You now know the difference between hardware and software, you know the tools needed for programming versus servicing, and you know how to handle all this equipment safely. But, knowledge is just the first step. The real question is, now that you've mastered the foundational tools of ICT, what real-world problem are you going to choose to solve with them next? Are you going to build a brand new app or fix the networks that connect us all? Keep exploring, keep learning, and I'll catch you in the next explainer.